All right, this is the second video in the lesson for area and volume. Here we're going to be looking at finding the volume of standard three-dimensional shapes, including prisms, cylinders, pyramids, cones, and spheres. Here we're looking at some prisms. I'm going to be given the description, not the definition of these objects. The base, I'm going to do some little bit of a highlighting here. The base is a polygon. So there's the base of the triangular prism. Here's the base. Oh, also you can think of the second base back here, and similarly there. So the bases are polygons, and the sides of these three-dimensional objects, the sides are rectangles. So can't see that blue on blue very well. But here, the sides are the rectangles. So in a rectangular prism, the sides and the bases can be interchanged because they're all rectangles. But it's a good idea to keep this description in mind. So the formula is base times height. Now, when we talked about area of objects, we often talk about base times height. Notice that this is a capital B that we use for the area of the base, and we're multiplying that by the height. So let's look at a simple example here. So the volume of a prism is equal to the area of the base, which I will have as 6 times 3, times the area of the height, which is 4. And that turns out to be 72 centimeters cubed, or cubic centimeters. A cylinder is a three-dimensional object where the base is a circle. So there you can see the base, and there you can see the base. And the side, and I put that in quotations because we don't really have a side of a cylinder. It's called the lateral face, but it's all of this right there. And the side is a rectangle. So if we unfolded that shape, we would have a rectangle there. The formula for the volume of a cylinder is, again, base times height, and the base is the area of the circle. Area of the circle. So here, base is pi times radius squared multiplied by the height. So in this example, the volume of a cylinder is equal to the area of the base, so pi times 4 squared times the height, 10. And so an exact answer here will be 160 times pi cubic inches. And if we want to get an estimate for that, we multiply 160 times pi, we get about 502.7 cubic inches. So here the area of that circle times the height. A pyramid has a base that is a polygon, and again, the sides are triangles, and sides is in parentheses because they aren't really sides, they're lateral faces as well. So the base here, there's the base of the square pyramid, here's the base of the rectangular pyramid, and there is the base of the hexagonal pyramid. And the height, it's important, intersects, it comes down from the apex down to the base, and it intersects at a right angle. So that is an important feature, and I guess that's true of all of these heights. I just didn't say it. So the formula for the volume of a pyramid is 1/3 times the base, which is the area of that base, whatever the polygon shape it is, times the height. All right, so here the volume of the pyramid is equal to 1/3 times the area of the base. Since the base here is the square, we have 8 times 8 will be the area of that square, and the height here is 9. So we have multiplied by 9. And that turns out to be 192 cubic centimeters. Here we have a cone. The base of a cone is a circle. So here's the base. And again, the side, which is the lateral face, is a vector of a circle. So here, if we unfolded this, it would look like this. So it really is a vector of a circle. And we can notice that when we talk about the base here, that's going to be pi r squared. So the formula for the volume of a cone is 1/3 times pi r squared times the height. So in this example, the volume of the cone is 1/3 times pi. The radius here is 7. So times 7 squared times the height, which is 18. So here we have the area of the circle, and here we have the height. And the exact answer there is going to be 294 times pi cubic units. And since there is no units represented, we'll just use the generic units. So if we want to get an estimate of that, we multiply the 294 times the pi, and we get approximately 923.6 cubic units. And I'm just going to do a U there instead of writing out units. That's fine. Our last shape is a sphere. A sphere is a shape that is perfectly round. All of the points are equidistant from the center. So we can think of the center there. And then that will be the radius of an infinite number of circles. And there are all kinds of circles running around there in the sphere. The volume for a sphere is 4/3 times pi times the radius cubed. So we'll look at this example. Volume of a sphere is equal to 4/3 times pi times the radius. And here, be careful, we are given that this is 28 centimeters. So that's the diameter. So the radius is actually 14 centimeters cubed. So our exact answer here is going to be 3,658.6 repeating times pi cubic centimeters. And when we give the estimate there, it's going to turn out to be approximately 11,400 494.0 cubic centimeters. And if you're wondering why I would say zero point 0, well, if you look at the decimal, it's 0.04032, and then it'll continue on. But the 04 rounds to zero point 0, and we just want to show that that's the significant digit with which we rounded to. And that is the end of volume. I hope that these videos make sense. Please make sure to ask questions or comment below. Thank you very much. Have a good one.